x86, RISC-V, and the ARM. And mostly the monopoly is for x86. And inside x86, we have AMD and Intel fighting for their positions as their CPU percentage. So this like this, we just see that the left hand side and the right hand side is my core work which I'm currently doing. So you can see and you can have an overview what the complexity is when we say VLSI. This all complexity comes. Okay, so let's move to another slide where so talking about VLSI application. VLSI is applicable everywhere. We have VLSI in the car, in the automotive domain. Like let's suppose there is a tie-up between AMD and Tesla, that Tesla will use AMD CPUs in every what to say, in every of the car which Tesla is like doing the production. We have AMD EPIC servers in the cloud domain. We have microprocessors. We have microcontroller. We have everything. Today's in this world is made of hardware, and today's hardware is basically comprises of this VLSI only. So if you just say that today, if you are doing something, you need VLSI. So VLSI is growing exponentially. It's not like that. The days has been gone like where you will say that VLSI is not growing exponentially. If we just see a VLSI growth potential in India, as we say that previously before 4 years before, there were not much more jobs in VLSI, but now the market is very much hot. You can get very easy jobs in VLSI. You can be a front engineer, you can be a back-end engineer, you can do everything whatever you like. You want to be inside VLSI. So let's suppose currently if we just see the worldwide semiconductor is growing in a very faster pace now. Even the software companies are moving towards the hardware. Even now Apple has just started its own CPU. We have Google inside. Google is moving from software to hardware domain, and Microsoft is also key interested in building their own hardware.
Excuse me, sir. So you are saying that the many big MNCs are going from software to hardware. So how to understand this thing? In which domain or how they are moving into shifting to hardware?
Okay. Let's suppose take an example of Apple. Previously Apple has its own MacBook, and Apple used to take Intel CPU inside Apple MacBook. But now Apple is trying to produce its own CPU instead of buying it from the Intel. Let's suppose you are buying something from X players and you are getting at 100 rupees. But if you can produce yourself, you have the capacity, you can do everything. So you can do it within 50 rupees only. So Apple is doing that thing only. So bigger software players are also trying to build their own hardware instead of buying from somewhere else. But still, they have not got so much proficiency. If you just compare a x86 CPU of Intel or either from AMD, when you compare with Apple, I think Bionic. I don't remember the chip name of Apple. Let me just Google out. Just give me 2 minutes. Okay. They have named it as M1. So if you compare M1 of Apple with AMD or Intel x86 processor, they are far in terms of processing capacity. They are far. AMD M1 is lagging much more behind than AMD's or Intel x86. But still they are applying their hands and moving from software to hardware so that they can produce their own hardware within coming say 5-10 years. They can be a master player inside the hardware also. But let's see, building a stable hardware is not so much easy. Okay, so that's what they are thinking. Their mindset is that they can produce their own hardware. Yeah,
It's
I
a,
think we have.
sir, one
Sir,
thing I
one
wanted
thing
to
I wanted
ask,
to ask,
like
like
earlier also
earlier
you
also you
mentioned
mentioned
about the
about the
floating
floating
point
point
architectures.
architectures.
Yeah.
Like,
So
sir,
like,
what
sir, what
changes
changes
are this
are this
floating point
floating point
architectures
architectures
bringing to
bringing
the
to the
VLSI
VLSI
design, and
design?
like,
And like,
is it
is it
somewhat
somewhat
different to
different
what
to
we
what
are
we are
doing
doing
right now
right now
with
with
gates? Like,
gates? Like,
what
what
is the
is the
difference
difference
between
between
that
that
floating point
floating point
architectures
architectures
and
and
the
and the
basic
basic
architectures which
architectures
we are
which we are
studying?
studying?
Okay, that's floating point comes when you do a CPU architecture. When you do a simple risk, when you do a simple architecture for an IP, let's consider I2C or SPI IP. Don't need a floating point architecture. I just wanted to show you the complexity what it comes when you, let's suppose you are doing something inside VLSI. So you need to have an idea about the whole architecture. Like let's say we are implementing I2C IP, you need to have a what I2C is, what I2C master does, what I2C slave does. I2C has a different modes. It can be slave modes, the master mode, multi master mode. So this all ideas should come when you are implementing something inside VLSI. That's what my main motive was. Like previously, when you do a software, you write a something piece of code. You don't need to understand the whole architecture. But when you are doing a hardware, you need to understand the whole architecture level flow. Let's suppose you're just let me give an example. Let's suppose you're building a mobile phone. So inside the mobile phone, we have cameras, we have graphics unit, we have a CPU unit. So if you're building mobile hardware, so you need to understand like, okay, this how that camera would be interacting with the CPU, how the data transfer should be there between CPU and the camera, or either how will you transfer your data from GPU to the camera. So this all information you have to keep in mind and then implement the hardware. So that's all. This all comes when you become a VLS engineer, and you need to understand the whole architecture first of all. It should be not okay. Okay, I'm just a hardware engineer. You can just play in your own role. It doesn't. It's just like if you're a software player, you can write the codes of a totally for the camera. You don't need how they will interact. Okay, this is my input and this should be the output, which you can have in the software. But in the hardware, you have to know all the whole architecture. Then only you can write your code, and then because everything is interlinked. Like let's suppose the data is flowing from hardware to GPU. There is a path. There is a hardware path. So that hardware path. So you have to implement. You have to lay out that data path. You have to provide the timing for that path. So for that you need to know the architecture. Okay, this is my data flow. So that's all my view was, like how, like you just wanted to make you all understand that how software is being different with hardware. Okay, so are you clear, Saurabh, or
Yeah,
you need some
yes,
help
Yes,
there?
sir.
understood, sir.
Understood, sir.
Thank you.
Thank you.
Yeah. So let's go to the next slide.
क्लासमेट्स को बोलो ज्वाइन करेंगे, बहुत कम पार्टिसिपेशन आ रहा है। बोलो फिर जब कंपनी आएगी उसमें बैठने नहीं
Generally,
दिया
we have
जाएगा।
a
ये लिख दो
VLSI
स्ट्रिक्टली,
myths and
वो ग्रुप
confusion
जो
in
बनाया था ना उसी
mind
में लिख दो
that
आई
which
आर ट्वेंटी
field
फोर
should I choose? Should I go to a memory team? Should I go to a FPG team? Should I go to a ASIC team? Or which team should I join? This is the basic doubt generally we have while while we are in a campus. So anyone can explain what's the basic difference between FPGA or like anyone is getting the idea what is IP, memory, analog, FPGA, something? Anyone can give me some ideas?
तुम आंसर करोगे?
मैसेज मैसेज सेंड करा था।
पहले आंसर कर दो, कोई बोल ही नहीं रहा है कुछ।
Okay. Okay.
Yes.
So the thing is, like when we are inside the VLSI, we have different fields. As I already told, there are memories. There are different IPs. IPs are the intellectual properties. Like let's
Have
suppose
you sent it?
IPs are, let's suppose when you are using a memory, it can be DDR5, it can be DDR3, it can be a SRAM or a DRAM. For writing those hardware, we need something like some protocols, how they will interact with something. So there comes the role of IP. So IP plays a role for the communication between two hardware. Or IP can be anything, like IP can be of DDR5, the IP can be of video protocols called RGB, uh, DVI, HDMI. So this can be some IPs. And memories, you already know, SRAM, DRAM, DDR3, DDR5. These are the memories. And now comes the analog IPs. We, like, let's suppose inside the world, like how data comes capture. First of all, the analog data is being captured with digital data. So we need some analog sensors also. So there comes the analog part. The FPGAs are the, I would say, the small, the gate arrays, the small digital devices on which you can, it's like a mini mimicking of yours, some of how to FPGAs, you can think as FPGAs are a small structure of hardware, where not hardware, a collection of gates which you can burn out to implement some features inside that. And AIML, you already all know. So let's come to like which field should you choose while doing a VLSI, uh, what we say, VLSI, while exploring your career inside VLSI. So are you all aware with VLSI flow? Anyone?
Will you answer? So,
So
first of
first
all,
of all,
we
we
actually
actually
design the
design the
algorithms,
algorithms,
and
and
once
once
algorithms are
algorithms are
designed,
designed,
then
then
we
we
move on
move
to
on
the
to the
FSM
FSM
part,
part,
and then
and then
FSM part,
FSM
and
part,
then
and
we
then
come
we
to the
come to the
physical
physical
design part,
design
which is
part, which is
again
again
uh,
uh,
like
like
much
much
complex
complex
process where
process, where
we
we
decide what
decide what
all
all
should be
should
the
be the
widths
widths
of the
of the
capacitors,
capacitors,
and
and
of all
of
what
all what
which are being
which are
used
being
in the
used in the
gates,
gates,
and
and
also the
also the
routing
routing
placement.
placement.
Like
Like
it is
it
all
is all
included in
included
that
in that
physical
physical
design.
design.
And
And
once
once
that's
that's
done,
done,
then we
then
move
we
on
move
to
on
the
to the
packaging and
packaging
all
and all
those.
stuff.
Okay, that's a nice answer. Thanks, Saurav. Thanks for explaining this. Yeah. So first of all, as Saurav said, first comes the chip specification. So let's suppose if you're building anything, you need some specification, right? So this part is the chip specification part. So here comes, if we just divide the VLSI industry, it is divided into mainly on two parts: the back end and the front end. So for front end, we just like the whole mind of any architect, like the architecture development is done by the front end team. So if you want to develop something, if you want to innovate, you have to be in a front end team, which my thinking is. I might be wrong, but but if you just want to do an architecture level job, or you want to implement something in a new way, you have to be in a front end role, where you have to be in a micro architecture level role. Because after this, the everything like RTL synthesis, DFT, placement, routing, flow, it totally depends upon how the how the complex architecture is. Like what we need inside the architecture. Let's suppose you want to implement a camera. In that camera, you want three flashes. Like let's say you want three color flashes. So that should be that would be implemented by the architecture team, that would be implemented by the architect people which are sitting inside the front end team. So the real brain comes from the front end mind. So here we decide what would be chip specification, how would we write the then after deciding, okay, this is the chip specification, then we have to write the Verilog code for it. Verilog code, or a system Verilog code, or we'll use any HLS language to write the codes, the chip specification, the hardware specification language. Then whenever you write your code and everything is done, the linting, the front end checks, which includes linting, CJC, VCLP, So these are the basic front end checks, so that we have to do while doing a front end design. Then whenever your front end is done, then let's go to a back end team. No, before going to the back end team, you need to do a verification. Okay, if you have done your design, then you need your verification team to, sorry, verification team should verify that whether you have implemented in the correct way or not. So after, okay, now if the verification is correct, you will move to RTL synthesis. RTL synthesis is like you did your RTL coding. Now the real gates will come in this place. You will implement, like, your ports would be replaced with the real hardware. You would have real gates, the AND gates, the OR gates, everything comes here. And then after your synthesis done, after your chip is done, you do a chip partitioning. Like, okay, this is the block, this is the A block, that you have SMU blocks, you have a north bridge, you have a south bridge. This all comes when you do a chip partitioning. So then it comes a DFT. So this all comes inside the backend flow. So depend, like, which field should you choose? It totally depends upon your skills. Let's suppose you want to be a front end team, so you should go to a front end art design engineer. You can be art design engineer. You can be architect. You can be an architecture role. If your skills, like, okay, you want to do a good timing analysis. You are very good in doing, like, you are very good in implementing the timing paths. You are very good in implementing the digital logics. So you can choose the backend team. If you are very good doing in schematics, so you can go to a floor plan team. Then the question comes, how that interest will come. Who will tell that, okay, this is your interest, you can boom in that area. So that can be only done if you just have a quick overview of all this. Okay, you just go to the website. There are many websites. You can just type in the Google and tell, like, let's see what DFT is. Just click on it and see what DFT is, and you will find, okay, this is the basic DFT pattern. This is M-based. This is when you just read about this, you will get an overview. Okay, then you will be able to connect yourself with the VLSI job opportunities which are there inside the market, and then you can choose which field you want to choose, and then you can pursue your VLSI career. Any questions from you all up to now?
You want to ask a question? पूछ लो कुछ.
Sir, like
about
the physical design,
like
like it's not being
taught
taught
at
at that
level
level in the
at the
at the
UG
UG
level,
level,
right,
right,
at the
at
college
the
level.
college level.
So
So
is
like,
it
is it
expected
expected
from
from
a
a
UG
UG
student
student
to
to
have
have
the
the
knowledge
knowledge
of
of
physical
physical
design
design
as
as
well?
well?
Uh,
Uh,
Okay, that
so
I also have in my slide. That I will explain you in my further slides. I have something for you all,
okay,
like how to prepare for everything.
yeah.
yeah.
That's your question is, right?
And sir,
And sir,
for that
for that
also,
also,
like, is it
is it
necessary for
necessary
us
for us
to have
to
some
have some
hands-on
hands-on
experience
experience
with the
with the
FPGAs, or
FPGAs, or
like, is
like,
it
is it
okay if
okay
we
if
have
we have
only,
only,
being much
being much
familiar with
familiar
the
with the
Verilog
very long
coding,
coding
and
and
also the
also
basic
the basic
softwares or the
softwares or the
simulating
simulation
simulation
softwares?
softwares? Like,
Like,
is
is
Look,
that
that
all
all
done?
done?
when companies come to undergraduate level, they don't expect you that you have the skills on the particular tool wise. You should have the basic skills. At least your digital logic should be clean. At least you should have some front end knowledge, but at least your basics. Let's suppose at least you have a basic idea about PD. Let's suppose you are applying for a physical design team and you don't have an idea about what STA is, what placement is. Like, at least you should have a single line answer for that. They don't expect. They don't want a master's. They just want a beginner. Like, okay, that person has some knowledge upon that path. That's all they
So
expect.
like, so like what I have understood is that, okay, that there are 11 stages. We could be at any one, but still we should have a basic idea of each and every stage now.
Yeah, exactly, exactly. That
Yeah.
was. Can you just give me? Can you just on hold for a second? I'm getting an urgent call. Just give me 5 minutes.
Sure, sir.
Sure, sir.
अगर वो कुछ बोले तो बीच में संभाल लेना, मैं भी आया। चेयर को ये ऊपर कैसे होती है मुझे? ये ऊपर कैसे होती है?
ये जो है ना, इन दोनों से ट्राई करो।
ये
इस वाले से जो फर्स्ट वाला है ना, इसको नीचे प्रेस करो।
ये वाला।
Okay. Sorry for the interruption. Yeah.
इसको लूज कर लो।
So that's all. Like let's suppose you are applying, but the basic thing is that at least you should have a basic knowledge, and for that you can always contact me. I'm always available on LinkedIn. I can give you all the overview which you want, and I am currently driving one interview sessions for all the undergraduate people, and I have already forwarded some of the links to Saurav. From there you can apply for it. We generally take sessions like how to clear all your interviews. We are already tied up with Triple IT Delhi, where we are giving some sessions over there. So that's what I also want in same thing in NIT Jalandhar also. So our students also get placed in VLSI fields. So the next slide. The VLSI myths and confusion which you have. Okay. There is the resources and skills which you the Saurabh was talking about. What exactly you should have when you are applying to a role inside the undergraduate people should have while applying to a VLSI job. So I would not say that you must be mastered in everything. If you're just applying to a front-end role, at least you should know the basic of any HLS language. It can be Verilog, System Verilog, or VSDL. But focus upon Verilog. It's a very easy language, which I can say. Verilog is the fastest and very easier language which you can understand in a very short span of time. What I can say. After Verilog, I think Verilog or VSDL is being taught in our curriculum. So from there, you can have an overview what Verilog is, and then you should have a basic microarchitecture understanding, and you should at least implement an IP, a small IP. It can be UART, SPI, I2C. That should be inside your resume. That will you can implement a simple FIFO. That will make your resume much more stronger when you are applying to any of the role. It can be back end, it can be front end. But before going to any of the team, at least you should have 1 or 2 VLSI projects. And then after, like if you are applying to a verification role, so you should have a good understanding about any of the what we say TCL, Perl, TCL, Perl, or Tickle. Use this. What we say exactly, I don't remember the term name, what term we call it as a, but at least you should have a basic understanding of Tickle, Perl, or Python. You can choose any of the language and you should have a basic understanding of this. And then it comes for the verification, you should have a system Verilog knowledge as well as the UVM or SV, at least basics knowledge. And when you are applying to a PD team, so at least you should have a basic idea about STA, what setup time is, what hold time is.
So like what is STA?
STA is a system timing analysis. Let's suppose, as I already told you, that there is data path. Well, when you have two flops, I think in which you are, what is your current year, like in which year you are?
Sir, finally graduate.
Okay.
Like, graduating this year.
Okay, you are graduating this year. So you might have been taught the step time and the hold time, right? So when you come to the real data path, you need to calculate that step time and the hold time. So that calculating, when you you need to calculate the timing path for all the data paths or the clock paths or the critical paths which you are using. So that is being done by a STA engineer. We call it static timing analysis. There are two type of timing analysis: the dynamic timing analysis, the STA timing analysis. DTA is generally done by synthesis people only, and STA is done by the STA engineers. I hope you're clear with your question.
Yes, sir.
Okay, and then comes the backend. So I would not say so for the backend, as you already said, at least you have basic knowledge. That's all you should have in the terms of resources and skills. And finally, I would say uh, look, there is a very good tool which is available on the college side. Xilinx ISC design tool. In when you open a Xilinx ISC design tool, you can do your design, you can do synthesis, you can do implementation, you can place and route, you can do from the front end to back end. You can do everything in that tool. But that tool is a FPGA tool. So I would say at the college level, you should have a hands-on experience on that tool, which I would say that you can have in that part. And these are some of the company level tools which we use inside industry. Like let's suppose if you're doing a front end checks, then you need to use spyglass or zero in tool. Then when you are doing a verification, then you would be using Costa Sim. When you are doing a synthesis, then you can use RTL compiler, you can do a DC compiler. That's all. These all are just what we say industry tools that you will get to know much more inside the industry when you join a VLSI uh, industry. And the final I would say that's all from my side. I will left the session to you all guys, that now you can have any questions from your side.
So, like you were saying that, like your company or from where you come, like you provide some sort of training in getting interviews of the
Yeah.
VLSI. So,
Yes.
like, sir, what is the registration charges and what is like the complete scenario, complete information?
We do it all free. Everything is free. Like we don't take any charges from the students.
Sir, like, okay, sir. Like, how to contact you, like, afterwards?
You can approach me through LinkedIn. I'm available on LinkedIn. You can.
Okay,
And
okay.
for if you it's like I'm telling you in an open meeting. Like if you want to apply for any company, like it can be Qualcomm, Synopsys, any company, just approach me on LinkedIn. It's my responsibility that I will refer you in that company.
Okay, sir.
It's like anyone, like if you want to join any company XYZ, any VLSI industry, it's my responsibility. I take my responsibility to refer you in that company.
तुम्हारा क्वेश्चन है
Sir, some questions which we had already, collected. So, sir, like one question which was being asked was that there are some disparities being observed in the, job offers being given in hardware versus software. So, do you think that that these disparities will be, getting diminished by the as the time passes?
I think nowadays hardware people are getting much more salaries as compared to software people. Like when you compare, like currently Amazon has started their hardware team in India. Generally, what Amazon pays, I'm just giving an example. Let's suppose they give freshers 25 LPA. Now they're paying at 35 for the hardware engineers, because nowadays we don't have much more hardware people inside. Uh, like you are telling the things which are previously that 3 4 years, but now the trend has totally reversed. People are getting much more in the hardware when you compare it to the software. But first of all, the thing is like your passion. You should not join VLSI industry just for money. Like passion is all about. Like let's suppose what you are in studying. Like let's suppose you're studying anything inside EC, that you are implementing that inside when you are inside the VLS engineer. Let's suppose like Indu Saini ma'am taught me what setup time is, what hold time is. I still know. I was being taught in this digital design. What we say, digital electronics, and she taught me. And even like there was a question in the major examination: what is setup time and hold time? I just wrote like before the clocking it, there should be minimum amount of time that data should be hold. So at that, I know like it was a 1 marks question, and even in this ma'am gave me just a half marks only. I know, I just remember those all the incidents, and when I implement that setup time and hold time now, I just feel that time. Okay, what I have been taught in my college days, I'm implementing those here. So you can relate your passion. So VLSI is all about passion, which I think. Although you need money to survive, I get that, but money is the secondary factor which will come after passion. When your passion is towards VLSI, then you will definitely get money. So I would say, if you want to join VLSI industry, be focused towards your curriculum, uh, like digital design, digital synthesis design. Even I think Sareen sir would be taking microelectronics.
So
So
Sareen sir
Sareen
has
sir has
left the
left the
institute, like
institute,
he has
like he has
retired.
retired.
Oh, because at our time, Sareen sir was taking microelectronics, and like he is one of the like I like the way he taught. There are many like the teachers all are good in our colleges. They are very much even calling Indusani ma'am or Mamta Ghosla ma'am, the Ghosla sir. Everyone is like great. I would say they taught us in a very good way. I can say that,
तुम एक क्वेश्चन पूछ रहे थे मुझे
and very much
मुझे मैम
thank
को
you
बुलाना है
from the
कोई भी
NIT
क्वेश्चन पूछो
teachers that whatever I am currently in my life, it's just because of NIT.
हेलो मैम वो अभी एंड करना है सेशन तो मैम आप
Hello Ranveer,
वो
how are
मैम
you?
मैम बैच नहीं याद आ रहा लेकिन वो भी आपको याद भी कर रहे थे कि ममता मैम
Hello
आएंगे तो
Ranveer,
मैं
I'm
सोच रहा था कि एक बार
Hi
पूछ
ma'am.
लूँ
how are
आपसे
Hi.
you? Hi. Okay,
दो
actually
दो हजार
presently I'm
तिरासी
out of
सतारह के
town, so I'm not able to switch on my camera.
मैम व्हाट्सएप
Yes,
पे
ma'am.
भेजा है
So good to see you after so long.
रणवीर सर
Yeah, same here, ma'am. Same here.
हाँ
So how's your job going on?
Uh,
Good.
it's very good, ma'am. Because of your blessings and your teaching, I am there. I can say that. And currently, I would be soon. I would be shifting US AMD CPU US team.
Okay, good.
Yeah, that's all just because of your digital electronics. I can say.
Now I'm hearing you are saying that I gave you half mark
Yeah,
in that question.
yes.
Uh,
Just was a kiddie point, ma'am. Just
yeah, I
yeah.
know.
I
So
still
it's
remember
good.
those days.
Yeah, good. So your juniors, maybe they will be must be get benefited from your talk also. So maybe they are not now they are interested in hardware because all of them are saying no, we have to go to IT companies, software. They are not taking seriously labs also and theory also because ultimately we have to go to IT companies, isn't it? Saurabh?
No,
Is it
Yes,
so?
ma'am.
Yes,
No?
like currently that
Trend
trend
is
is kind of
what ma'am
what
said,
ma'am
but
said,
I
but I
think that
think that
after
after
what
like
sir
what
has
sir has
motivated all of
motivated all
us,
of us,
Yeah,
it will
it
really
will really
change.
change.
yeah. Okay, Ranveer, all the best for your future.
yeah, thanks, ma'am.
Okay, bye bye.
Bye, bye.
Mamta ma'am has
Mamta ma'am has
also joined
also
us.
joined us.
Mamta ma'am, you are
Mamta
not
ma'am, you're not
audible.
Voice is
audible.
breaking. I'm not.
Yeah.
Yeah.
Hi, ma'am. Good morning.
Am I audible now?
Yes, ma'am. Now
Yes,
you're
ma'am. Now
audible.
you're audible.
Okay. How are you, Ranveer?
I'm fine, ma'am. What about you?
I'm good.
Yeah, thanks for asking, ma'am. I still remember digital synthesis design from you.
Okay.
Yeah. This
So thanks for connecting with the students. And
yeah, it's all pleasure
actually,
of mine, ma'am. It's all pleasure of mine, man. Yeah. So I still remember those days. That was very good, ma'am. Because of you all, I have been like whatever in my life is.
So we are also proud of you. Uh,
Yeah,
you have been so successful in your life, and we hope that you will remain in touch with the current students, keep guiding them so
yeah,
that they are
definitely.
also able to achieve great heights in their lives.
Yeah, definitely, ma'am. Definitely.
So I hope the session was useful for the students. Uh, Saurabh?
Yes, ma'am, it was really nice, and we really got to know much about chip designing, like how all it goes on in the industry.
Yeah, ma'am. And I'm also trying
Ranveer,
to.
AMD से
And I'm
हाँ,
also trying
my
to bring.
question was that
Hmm? Continue, ma'am. You can first continue.
my question was AMD. Can you connect us with AMD, or can you arrange that for this thing that AMD also visits campus for
Uh,
internships and for placements?
yeah, ma'am. Definitely. I have already also asked Saurabh for some of the resumes, even for my team, for internship. I have already spoke, I have already spoke for that previously also with Saurabh. So I want some resume even for my team only. They will be directly placed with AMD as internship as well as the full time in AMD. And I'm also trying to bring AMD in our college.
So what will be the formal procedure that we should follow? Because we have designed a brochure, so we can send you the brochure in which we have mentioned all the skill sets of the students.
Mhm.
So Saurabh will send that brochure to you, or through head mail we'll send that brochure to you, and then based upon that brochure you can communicate it to the HR of your uh,
Yeah,
industry
sure,
and
ma'am. I will do one thing. I will connect Saurav with Indian HR, Indian college HR.
okay.
They will directly talk to Saurav.
Yeah, and
Otherwise,
we
you
have
are visiting other NITs for.
Yeah, ma'am. I have definitely
Sorry.
like. Yes, Saurav, you can continue.
Yeah, ma'am, we have collected the resumes. We'll send it to sir.
Sending
Sir,
AMD.
sir, like many students wanted to know like what all were the like
हाँ
basic
सौरभ
thing,
बोलो.
like most of the students what they're having in their resumes is like software projects. So they were asking some of the tips for the resume, if you could give it.
Okay, yes, Saurav, let's do one more session in which we like give me some of the resumes. I will scrutinize them, and I will tell how to rectify those resumes. Like I have already taken like currently ma'am, I have already involved in IIT Delhi, Triple IT Delhi. Like we are taking some sessions in Triple
Okay.
IT Delhi, and I was trying to approach our college also. From there, I got contact with Saurabh. So we are taking some sessions like how we can rectify our students and enroll them in the VLSI industry. That's all where our role is. And currently, I could say I have many contacts in many of the companies, not even in AMD. I can like let you connect with Qualcomm, uh, Nvidia, talking about Intel. I have many contacts, ma'am. This I can very proudly say.
Ranveer, Intel, Qualcomm are already visiting the campus.
Okay, ma'am.
So, yes.
That's
So I
great, ma'am.
wanted to know that what is the process for AMD. We want that you people also should come to the camp. Are you visiting other NITs
Yes, ma'am.
for campus placement?
Previously, I have like I was a part of team. We have visited IIT Delhi, ma'am. IIT Delhi and IIT Bombay. But I'm trying to
Okay.
like I'm telling them to visit our college also. So that's what like my
See, you
manager.
should. You should.
Yeah,
Ranveer,
ma'am.
if you are so successful there, then you must encourage them to go to NIT, because one of our best product is with them.
Yeah,
So you
definitely,
should
ma'am.
encourage them to visit NIT Jalandhar also.
Yeah, ma'am. Definitely, I'm trying. Like I've convinced my manager. Like that's why I've asked
Yeah.
a lot of with some of the resumes.
Yes, sir. I'll send it
Okay.
to
Okay.
you by the end of the day.
Resumes, and we'll also send you the brochure.
Yeah, sure, ma'am. And I will try my
Yeah.
best to like. I have already talked with the head HR so that they can visit NIT Jalandhar.
Mm-hmm.
So this all I've
Okay.
already
Okay.
doing with the background before, like before coming this meeting also. Like I was like, if you even if you see your mail, I have already approached you earlier also, ma'am. There was a mail. There
Okay.
would be a mail from my side.
Mail to you
Uh,
mailed to CPO or to the head electronics
I have mailed to
department?
everyone, ma'am. Indusani, ma'am, to you, the Ghosla sir, everyone.
12:30 पे कल मेल
Okay.
Yeah,
Okay, I'll go through the mail then. Okay. Okay, thank you so much, Ranveer.
yeah. Thanks. It's all pleasure of mine, ma'am.
Indu madam, hello.
हाँ जी मैम, होगी मेरी बात रणवीर से.
Okay, okay.
Ranveer has designed.
ठीक है, क्योंकि आपको याद करा था ना.
हाँ, I know. They have designed the website for me also, Women's Health, and still we are using the same website. है ना रणवीर, याद है?
Yes, ma'am. याद है. तो प्रोफाइल टोटली चेंज हो गई. अब तो प्रोफाइल सीपीयू में. अब ये है कि मैम, एक्चुअली आई वाज थिंकिंग टू स्टार्ट अ करिकुलम फॉर रिस्क वी इन आवर कॉलेज, if you all apply, like if you all ready with it, like मैम हम छोटा सा इंटर्नशिप कर सकते हैं so that our college would have its own CPUs.
Yes, we can do. Yeah, we can include some more. Either we can revise our curriculum also, even in subject curriculum or whole curriculum according to your need, according to the industry need. Na? Some subjects we can include in our curriculum. Yeah.
Definitely.
अभी एक्चुअली हमें ना अभी करना है. वी आर इन द प्रोसेस ऑफ रिवीजन. सो हम आपसे इनपुट्स लेंगे रणवीर इसमें फिर.
हाँ, sure ma'am, sure, I am there.
हाँ जी.
And even ma'am, it's not like it's not limited to AMD only, ma'am. I am very much frank. I have told Saurav also, if you want to apply any VLSA company, it's my responsibility to refer you all.
Okay. See, through reference, it's a different thing, na? That will be an off-campus sort of arrangement for internships and for placements also. But I want that most of the VLSI companies should visit the campus.
Okay, ma'am.
So if that can be arranged, that will be much better for all the students.
Okay, ma'am. For that, I can
see the problem, Ranveer. The problem with our students is that they are not interested to join the LSI companies, and the major reason that I have seen in the past is the in terms of the package. So I want the companies to visit campus so that the students also get motivated that these companies are. Students को क्या लगता है कि इंटर्नशिप के लिए ले जाती है VLSI वाली कंपनी, लेकिन प्लेसमेंट तो हमारी IT में ही होनी है. यहाँ थोड़ा सा प्रॉब्लम आता है और पास में आया है. तो ये जैसे अभी TI आई थी पीछे, TI में कुछ स्टूडेंट्स इंटर्नशिप के लिए सिलेक्ट हो भी गए, बट ज्वाइन करने में इंटरेस्टेड नहीं थे, बाद में बैकआउट कर गए. तो TI पे भी एक इम्प्रेशन बहुत खराब गया और उधर से मतलब हमें लगा कि स्टूडेंट्स आर नॉट एट ऑल मोटिवेटेड टू जॉइन द कोर कंपनीज. वो एक चेंज करना चाहते. हाँ जी
मैम, प्रॉब्लम मैं आपको एक्सप्लेन करता. प्रॉब्लम कहाँ आता है? प्रॉब्लम ये होता है कि जब इंटर्नशिप के लिए कोई कंपनी लेके जाती है तो वो आपको कोर वर्क नहीं देती है, आपको एप्लीकेशन इंजीनियर का वर्क दे देगी, कुछ भी मतलब कोई रफ वर्क दे देगी. तो बच्चों को ये लगता है कि यार ये तो बहुत बेकार काम है, क्योंकि इंटर्नशिप में वो रियल वर्क देते ही नहीं है. प्रॉब्लम यहाँ पे आता है बोले, और वो उनको लगता है ये सॉफ्टवेयर काम है, इसीलिए वो ज्वाइन नहीं करते. ये वन ऑफ द रीजन है जो मैंने देखा है. सो इस पे भी हमें फोकस करना चाहिए कि आप जो बच्चों को लेके जा रहे हो एग्जैक्टली आप किस चीज के लिए लेके जा रहे हो, तब भी मतलब उनका इंटरेस्ट डेवलप हो पाएगा. और या फिर उनका माइंडसेट आपको बनाना पड़ेगा कि आपको इंटर्नशिप में एक सही मतलब स्किल्स, आपको सिर्फ एटलीस्ट यू हैव टू डेवलप द स्किल्स. आपको टूल्स पे अपने हैंड्स क्लियर करना पड़ेगा. तो तब आपके मतलब मैंने देखा मैंने बहुत से रेज्यूमे मतलब मुझको अप्रोच करते हैं NIT लंदन के स्टूडेंट्स, बट द प्रॉब्लम इज उनका रेज्यूमे ही बहुत वीक होता है मैम, जो कि सेलेक्ट नहीं हो पाता है. इवन मैंने प्रीवियसली ऑल्सो मैंने बहुत से सीनियर्स हैं NIT जलंधर के भी, उन्होंने मुझे रेज्यूमेस दिए हैं. बट द प्रॉब्लम इज हमें एटलीस्ट वी शुड वर्क अपॉन अ स्किल्स. जब तक स्किल्स डेवलप नहीं होगा उनका रेज्यूमे शॉर्टलिस्ट नहीं होगा.
तो हम जैसे अभी आप बात कर रहे थे, कैन वी हैव अनदर सेशन ऑफ योर्स विद द स्टूडेंट्स जिसमें आप इनको यू गाइड देम अपॉन मतलब क्या चीजें, व्हाट स्किल सेट्स दे नीड टू डेवलप ताकि उनका जो रिज्यूमे है उसमें वो क्लियरली रिफ्लेक्ट हो एंड मतलब ऐसा कुछ कर
श्योर।
सकते हैं आगे।
हाँ श्योर। श्योर श्योर मैम।
ओके ओके ठीक है रणवीर, ठीक है।
ये और
चलिए
और एक चीज है मैम, जो
हाँ जी हाँ
खोसला
जी।
सर के द वे खोसला सर के थॉट्स एंड मैम अब मुझे समझ में आता है कि व्हाट ही वाज एक्सप्लेनिंग अस इन दैट क्लासेस, वो चीज मैं अब इम्प्लीमेंट करते हैं। जैसे जब व्हेन ही वाज टेकिंग एआईएमएल क्लासेस, अब वो चीज मैं इम्प्लीमेंट कर रहा हूँ, तो वो चीज अब मुझे समझ में आता है। तो आई वुड से स्टूडेंट्स को कि अब भी मतलब वो रिलेशन जब आप इंडस्ट्री में जाओगे तभी आ पाएगा।
चलिए ठीक है। Okay, thank you for joining, Ranveer, and thank you for giving such valuable inputs to the students. And we hope that we'll arrange one. सौरभ, आपकी responsibility है, आपने इनको छोड़ना नहीं है। एक और सेशन रखना है जरूर, ठीक है?
Yes,
Yes,
ma'am.
ma'am.
Sure,
चलिए, ओके
we'll.
जी। हाँ
Yeah, thanks Saurabh, thanks Mamta ma'am, thanks Indu ma'am.
ओके ओके ओके।
Thank you so
Thank you
much,
so
sir,
much, sir,
for
for
coming
coming
and giving
and giving
the
the
talk, and
talk, and
thank you
thank you
everyone for
everyone for
joining.
joining.
And we'll
And we'll
really be
really
in touch
be in
with you.
touch with you.
Yeah, sure Saurabh, sure. Thanks.
Thank you.
Thank you.
रणवीर, बाय बाय। ओके, टेक
Bye bye.
केयर।
Take care ma'am. Bye bye.
Thank you, Ranveer sir.
Thanks.
Thank you, sir.
Thanks.
Thank you, sir.
Thank you, sir.
Thanks all.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.